Hello and welcome to the video. I'm going to try to show you how to access some chemistry simulations here through a program offered through the University of Colorado. So right here on the screen, I've just done a Google search for PhET here. So it's PhET, right? And it's a capital H in the logo, right? But it's reversed here in the first choice. This is where we want to go, PhET at colorado.edu. So after searching PhET, that should be the first thing that pops up. We've got a bunch of interactive simulations for lots of different science classes. So here from the welcoming page, I'm going to click on Explore Our Sims. And I'm just going to scroll down a little bit into the chemistry section, since that's what we're interested in. And let's go to all of the chemistry. So there's a whole bunch in here, and you'll see a lot of these that link to some of the things we've talked about in class, but the one I want to show you today is balancing chemical equations. This is something people maybe struggle with sometimes, and I think the visualization here in the simulation might be able to help out. So entering into the balancing chemical equations simulation, we see a couple choices here, an introduction and a game. Let's go into the introduction first. So right here we've got an equation, right? We've got some coefficients out in front of each of the reactants and the product. We want to try to balance out the equation. So let's start by just putting one of each of the molecules in and see where we stand now. So we've got one nitrogen molecule here, so it's diatomic, so there are two nitrogen atoms. We've got one hydrogen molecule that's also diatomic, so there's two hydrogens here. You can tell the hydrogens from the nitrogens based on the color scheme here. The little white spheres represent the hydrogen atoms, the blue ones are representing the nitrogen atoms. And over here on the product side, we have one molecule of ammonia with the formula NH3, so there's one nitrogen in there, and three little hydrogen atoms. Now, we've talked about conservation of mass and how when we do a chemical reaction, we should have the same mass on the reactant side over here to the left of the arrow as we have on the product side to the right of the arrow. And we can simplify that by counting each type of atom on both sides of the reaction. So if we have two nitrogen atoms over here on the reactant side, there should be two over here on the product side as well. And this is not a balanced equation because we only have one nitrogen atom here on the product side. Well, we can fix that. I'm going to click the arrow here to raise the coefficient in front of ammonia and add another ammonia molecule. So now you can kind of look at the picture. There's one nitrogen here in the top ammonia, one in the bottom ammonia for a total of two nitrogens, two nitrogen atoms over here on the reactant side as well in the diatomic nitrogen molecule. So at that point, nitrogen is balanced. But we would need to factor in any other components of the equation. There's two hydrogen atoms over here on the reactant side. But looking over here on the product side, there are six hydrogen atoms. So we've got more on the product side than the reactant side. Well, we can adapt to that by changing the coefficient here in front of the formula for hydrogen. So if I click the up arrow there and change that to 2, we're a little closer now, but still not balanced. We've got two hydrogen molecules for a total of 4 hydrogen atoms now on the reactant side. But we still have 6 hydrogen atoms on the product side in those two ammonia molecules. So I need to do this one more time and get 3 hydrogen molecules over here on the reactant side. And you can see up at the top of the screen, the happy face, we now have a balanced equation. We have the same number of each type of atom on each side of this particular reaction, and this one is balanced. So you can see down here at the bottom, there's some other reactions you could try out here. So I'm going to leave those if you want to come in and try this out on your own. Let's go back out to the beginning here and take a look at the other option, which is the game. So if I click on the game here, right, a couple different levels, so you can kind of build up your skill here if you want to play the game. And we've got a reaction here, CH2O plus H2, and over here we're making CH3OH. So looking at that, let's go to 1 here, that's 1 carbon. I would also want 1 carbon on this side, so I'll need 1 of that molecule. Now let's see if we can fix this just by changing the hydrogen. There's 1 oxygen here in the reactant, 1 in the product. So right now, carbon and oxygen are both balanced. Can we balance the hydrogen? 2 hydrogens here in one of our reactants. Right? If I put 1 hydrogen there, that's a total of 4 hydrogen atoms on the reactant side. Right? And in this structural formula over here, the hydrogens are separated, but 3 plus 1 is a total of 4. That looks like it's balanced with just 1 of each. I can check it's balanced. I got 2 points, right? And I could go on to the next problem. So I'm going to leave those for you to practice as well, but this is kind of a good visual way for you to get a feel for balancing equations, maybe get a little extra practice, right? A little more fun setting than what we see in the textbook.